Hello, and welcome back to the Predictive Modeling Fundamentals 1 course. This is Lesson 2. Speaking to you today are Mikhail Lakirovich, Product Marketing Manager for IBM Predictive Analytics, that's me, and Arman Ruiz, Product Manager for IBM Predictive Analytics. So in this lesson, we will pick up where we left off. We will discuss the first steps of the CRISP-DM methodology. We will discuss data preparation and data pre-processing, and then we will perform data preparation with SPSS Modeler. So our agenda for today is we're going to start with the first step of CRISP-DM, the business understanding, and we will discuss the use case that we will be using throughout the rest of this course. We will go over data understanding and go over the tools for data exploration that are available in Modeler, and then we'll go on to data preparation and pre-processing, and we'll review the tools that SPSS Modeler affords to be able to do that. And then we'll go into a lab and review a solution. So the first step of CRISP-DM, again, is business understanding. Without knowing what exactly the objectives and requirements are for the project, the chances for the success of a data mining task are reduced. You have to be able to know what you're going to do, and you have to know what you're going to look for, and you have to know what data you're going to need, and why are you doing it? So in our case, we're looking at the sinking of the Titanic use case, a very famous use case. The Titanic ship collided with an iceberg, and a lot of people have not survived because of a lack of life rafts, because of a lack of life jackets. So among the passengers that were most likely to survive, more likely to survive than others, were women, children, and the upper class. And our challenge for this project will be to analyze a data set and classify a passenger as whether they're likely to survive or not. And we're going to be doing that with data mining tools. So this data set, the Titanic data set, comes from Kaggle, and Kaggle is an excellent place to get started with data mining projects. It's a place for data mining competitions. A lot of data sets are publicly available there, and it's a great way to learn and explore data and get better at what you're doing. So for our cases, there's two data sets that are already available to us, the training data set and the testing data set, so we don't have to separate our data into these two subsections. So some of the tools available in SPSS Modeler for exploring data are available on the slide for you. You can see you can audit the data. You have a graph board that allows you to pick various graphs based on what data you have. You can do different plots and distributions and histograms and web graphs, and there's also evaluation curves that when you evaluate the actual model. So this is something we'll be using throughout the course. So when it comes to data preparation, this is where we create a data set from an initial raw data. And oftentimes data preparation tasks take a while to complete. There's multiple steps. They can be repeated in multiple times because oftentimes the data in the real world is dirty, it's incomplete, and that a lot of attribute values are lacking. For example, as you've seen here, you can have a gender of nothing, which is obviously not correct or does not add value. Data can be noisy, which means there's errors, there's outliers. It can be inconsistent when it comes to their namings, codes, or discrepancies between different tables. So we have to account for that, and we have to take care of that before we can run a model that actually makes sense and a model that is accurate. So some of the key tasks in data preprocessing are data cleansing, so filling in missing values, smoothing out data that's noisy, identifying, removing outliers, resolving inconsistencies. Then there's data integration, which is integration of data from different databases or files. Sometimes we have to transform the data by normalizing or aggregating. Sometimes if you have data, for example, you can have a rating data, but then you have income data because it's going to be so large, thousands of dollars, let's say, that can dominate your model. So we normalize this data and transform it so that one attribute or one variable does not dominate the entire data set. And then sometimes we have to perform data reduction, which is done by feature selection or feature extraction. So some of the common tools for that are principal component analysis or factor analysis. Basically, you are getting a reduced representation of your data. You're trying to capture as much variability in your data and as much information in your data, but present it in a smaller size, which a lot of times is necessary as a post-processing step, especially when data sets that you're working with are extremely large. So what are some of the ways to handle noisy data? One of them is binning. You can sort the data and then partition it into bins of equal depth, so same number of customers, let's say, in each bin. You can also cluster your data to identify where the data points in your data, how they align together, and this can help us aggregate data into clusters that are very similar to each other, but also that can also help us identify outliers. And then obviously expert knowledge is crucial because a model can detect potential outliers, but then that has to be validated by a subject matter expert who actually knows the data, who knows the space. So outliers are data objects that are very different from the general representation of the data, so they stand out. And sometimes outliers are made in error, and that has to be corrected. But sometimes outliers actually bring in valuable information, and they have to be included in the model. And this is where subject matter expertise, especially, really comes into play. When it comes to data transformation, this step allows us to smooth noisy data so that we're removing all the noise. We can sometimes aggregate the data. Like I said, we can normalize it on a min-max scale, everything from 0 to 1, for example, or on a z-score normalization, and Modeler allows us to do that. We can create new features or attributes with principal component analysis or factor analysis. So some of the tools that are available to us for data preparation modelers. So if we look at the type node, this allows us to define what type is each attribute in our data set. Is it a continuous data set, like income or age? Is it categorical, so string values? Is it flagged, yes or no? Is it nominal? Is it ordinal, where there's a particular order involved, or is it typeless? The type node, the way it's structured is you can set your data to be an input, which is used as an input or a predictor to the modeling technique. A target, which is the outcome that we're trying to classify or predict. It can sometimes be both. So it is used in specifically association rules for other modeling techniques. This will not be applicable to. Sometimes it's none when we want to exclude it from modeling. Or partition. That means we're using this variable to separate our data into samples for training, testing, or validation if necessary. So another important issue to deal with when preparing your data is handling missing values. And it's very important to handle the data beforehand to understand how to handle the data and to understand the data quality. Because, obviously, if you don't have poor quality in data, then it's going to be garbage in, garbage out. The results of the model are not going to be conducive to sound business decisions. And files or fields with missing data can produce misleading results if they're not identified prior to the analysis. So there's different kinds of missing data. You can have a null value or no value for a numeric variable. You can have a blank space for a string variable, or sometimes you can have user-specified missing values, like blank values. So for example, for children, that they can be colored in Modeler. It's 99, which shows you that this is a missing value. There's a really neat tool in Modeler called the Auto Data Prep node, and this node by itself helps you handle the data preparation tasks. It helps you to analyze the data, identify missing values, normalize the data if you want. So it really helps you take care of some of this messy work, which can be extremely time-consuming. A great number of record operations and field operations exist in Modeler that really make it easy to extract and transform and load data, so make the EDL process really easy. You can, sample the data, you can sort it, balance it out. If you have a certain class that's underrepresented, you can merge data sets, aggregate data, derive new variables, filter certain variables out, reclassify different variables, bin them, partition data into training and testing sets, convert a characterizable variable to a series of dummy variables. So there's a lot of things. Available in Modeler, and extremely powerful when it comes to these operations with munging your data. Another great thing with Modeler is the CLEM language, the expression builder, that you can use to, for example, derive a new attribute. And it's really intuitive. You can, as you can see, you can do everything with point and click. You can check if a variable is an integer variable. You can convert a variable to a date or an integer. You can sum different variables, and there's a lot of tools available here for you with this expression builder. So with that, let's go ahead with our lab 2. We're going to load the Titanic data, we're going to explore it, and we're going to prepare it for modeling. And we will see you in the next course.